does let me put a question mark on there. So page 44. Remember all the pages that I've assigned, the keys that are up, that's still there, okay, for you to try. But we're going to focus a little bit more on the next topic to see whether or not data is normally distributed. If data is normally distributed, the following would be true. 100% of the data is under the curve. The graph will be symmetric. You'll have a bell curve. The mean is at the center. Half of the values are below, half of them are above. That's where symmetry comes in, by the way. It follows, this one is big, I'm going to give this a different color. It follows the rule that all normally distributed data has to follow. The 68, 95, 99, that's like the key to whether or not we're going to, ultimately say that data is normally distributed. The mean, median, and mode are equal or close to each other. That's another indicator that your data is normally distributed. So I will say that I wish that data would always be perfectly symmetric, but it's not always. But this one right here, if you were to connect the tops here of this data, so this is what do we call this? A histogram, but the bars aren't touching, so technically not quite a histogram. But if you collect your data, you've got intervals, right, for your bars. This one is actually, this would probably be considered normally distributed. Okay. Although the graph is not perfectly symmetric, it could still be normally distributed. And we will have to do some further investigating to make sure that it is, or to either disqualify it or this one. I think you could probably guess that this one is not really going to meet the criteria if you connect the midpoints. Graph is shifted to the right, not symmetrical. Therefore, not normally distributed. Not normally distributed. You can share the joke if you have a good one. Okay? Not normally distributed. Okay? There we go. So sometimes the graph gives it away, sometimes it doesn't, right? So it depends on, we definitely will dig deeper than just the graph. Okay? Next, these are the steps to show if data is normally distributed. Okay? Determine the mean and the standard deviation. Sort data if possible. This is something that I feel like this is so much easier. Draw a line where the center is the mean and go up by 3 standard deviations. We're gonna keep it at 4 standard deviations just to make sure we include everything. This is what I call a frequency line. Make a frequency line. That's the second step. And then we create a frequency table using the standard deviation as the interval. Can I, hold on, question, sorry. The third point, instead of making a frequency table, I'm not going to ask you to do that. I'm just going to ask you to do a frequency line. So 2 is already getting you started for a frequency line. 3 is like we're actually going to come up with our frequency line, okay? And watch this. This is new. We're using our standard deviation as the interval width. I don't know if you remember, but the interval width, I would either give it to you or, but now we're going to use our standard deviation as our interval width. Okay. And then create a histogram or frequency polygon. And in table 3, does it look like a bell curve? I will make a note here only if required. I will not always require you to make a frequency polygon or a histogram. But this one is important. Check if data follows the empirical rule. We're going to see if 68% of the data falls within 1 standard deviation, 95 within 2 standard deviations, 99 within 3 standard deviations. Here's a different color probably. If data is off by more than 5%, we say that it does not follow the rule. That you need to remember, the 5%. If you're off by 5%, we would say, okay, it doesn't qualify, it doesn't meet the criteria. All right, let's try this. I'm going to ask you to do some clicking. Okay? Go to 45. Can you enter this into your L1, please? It's important that you do it so that we can walk through it together. So clickety click. Okay. You should also check, right? You've got 5 rows, 2, 4, 6, 8, 10. So 50 values. Actually, movies, right? Tegan is organizing her movie collection, so 50 movies we're considering. So N should be 50, okay? So let's determine the mean, median, mode, and standard deviation. We're going to go A, one variable stats, just L1, right? And so we're going to state the value. So stat, calc, one variable stats, second one, there it is, 102.5. And I've vetted this, so if you're not getting this, you got it wrong. You typed in a value wrong. Median is 99. What does the median tell me again? That half of the movies in this case are going to be shorter than 99 minutes, half are going to be longer than 99 minutes. So I've got that. Oh, mode. I haven't figured out the mode yet. I would sort, right? Sort in ascending order to make that happen. So we go stat, you go sort A, you tell it to sort whatever is in L1. Then when it says done, you can go back and actually check. And the mode is 89 has 1, 2, 3, 4 instances where 89 shows up. So that's my mode so far. But there's another one. If you keep going, 99 shows up 1, 2, 3, 4 times as well. So in this case, you've got two modes. If you think about it, the median, the mode, if you consider 99, and the mean, they're all pretty close to each other. That's a good indicator. Okay. Note, mean, median, and mode are close. Therefore, could be normally distributed. So we are already having a bit of an indication that this might be. Yeah. There is? Oh, I didn't do my homework. Oh, yes. My key says for, sorry, you got it. Thank you. That is correct. Yeah. Yeah. 3 modes in this case. All right. B. Do I have to make a change here? It says create a frequency table. I find frequency tables very painful for this application. We just want to know if this is normally distributed or not. So I'm going to ask you to, every time you see that, just go frequency line using the standard deviation as the interval width. I'm going to highlight that because that's new. Using the standard deviation as your interval width. So all I'm asking you to do is grab a ruler or just draw a straight line like this. And my ruler is actually pretty good. I'm just going to use that as my center. And I'm going to go 4 standard deviations to the left. Try to space them out equally. So 1, 2, 3, 4. And then you do the same thing going to the right. 1, 2, 3, 4. The mean goes in the middle. So the 102.5 goes here. This is not a line plot. You don't need to be too fancy on this one. And I create what I call bins. Okay, so I make the lines a little longer, and I'm going to put the values in here. So just basically just break it down. Okay, anyways. So here you have to pay attention, okay? This is the mean. So you're going to go up a standard deviation every time. Okay, that's what's happening here. Mr. Jackson, why are we going up 4? I thought you kept on saying 3 and 3. Like, what's up with the 4? It's just to make sure that you have a bin to place values that are so far outside the 3 standard deviations that you have a place for them to go. Okay? So you grab your calculator, you have to be careful here. 102.5, and then you're going to add a standard deviation. What is our standard deviation? Look up, and not up in the ceiling, just look up here. 24.73. So you're going to add, you got to be very careful. The mean plus a standard deviation. Oh, it's going to be messy here. I'm going to go 127.23. And you keep adding a standard deviation to this. The next one is 151.96. Another standard deviation. 176.69. One more. 201.42. Remember, these are minutes. And we're going to the left. What's going to happen? We're going to subtract the standard deviation every time. And to save you the trouble, I'm just going to give you the answer. So 77.77, and then it's 53.04, and then it's 28.31. I'll zoom in a bit here for you. 28.31, and then it's 3.58. There we go. So if you think about it, this is like the x-axis of a histogram or a frequency polygon. Grab your calculators now, and we're going to place in the values, just like we used to do with our frequency table. It's already sorted, okay? So 25 would actually fit in here. So 25. 73 is my next value, so you got to go find the right interval. 73 would actually fit between these two values. So 73. 78 gets me already into this one. 81, 84, 86, 87. Another 87, so you got to keep going. 87, 88, 89, another 89, so that's 5. Sorry, that would be 5. And then another 89, so I keep going. A 90, another 90, a 91, another 91. So this keeps going for a while. So I'm just going to do this here for you. There's 34 values in there. So this is 10, 20, 25, 30, and another 4. So there's 34 values in there. Actually write down the number up top. So 1 in here is 1 in there. Okay, so 1, 1, 34. Over here, you've got 7. 1, 2, 3, 4, 5, 6, 7. You've got 7 in that interval. You've got 3 in this one. You've got another 3 here. And there's another 1 out here. Probably what we would call the outlier. We can finish this. So this is B. C we will omit. We will not be making a frequency histogram or a frequency table in this case. D, are the lengths of the movies normally distributed? Check if data follows 68, 95, 99.7 rule. That's what we're going to check for here. So 68%, if this is your mean and you go 1 standard deviation to the left and 1 to the right, like if you add up these two, it should be 68% of the value should be falling in there. So we do this, plus or minus 1 standard deviation. That would be, remember, we're always comparing it to 50 values. We're having 50 movies that we're considering. We would have to add 34 and 7 together. And that gives you 41 movies out of 50 fall within 1 standard deviation. And that is 82%. Whoa. Versus what? What are we supposed? We're supposed to get 68%, right? Fails since we are off by more than 5%. Like you can't, like the greatest you could be off by, like if you had 73 or 63, right? Take away 5 or you're over by 5, that would have been fine, but this is you're not normally distributed. Okay. But we're gonna check for the other ones. Remember, we're checking against 50. If you go to the middle and you go 2 standard deviations to the left, that gets you to this line. You go back to the middle and you go 2 standard deviations to the top. That'd be all of these numbers right here. So that'd be 1 plus 34 plus 7 plus 3. And that is 45 out of 50. That is 90% versus 95. So it passes that test, that within 2 standard deviations you have about 95% or you're close. Technically it failed already because this one failed, so you technically are done, but I want to show you just in case you have to keep going. If you go plus or minus 3 standard deviations, watch, this is the middle, you go 1, 2, 3, so you would add up everything from here all the way to 3 standard deviations to the top. So everything except for 2. If you could just write this down, that's all I'm going to ask you to do. That would be 96% versus 99.7%. That also passes. Is data normally distributed? No, because it failed up here. I don't expect you to keep going when it fails, just stop. But I wanted to show you everything that goes with it. Not normally distributed. Okay. I will ask you to do one at least on page 47. Okay. And then we'll reconvene tomorrow. I have to talk about a few more things that you need to watch out for.